So what we do is we first of all import our necessary libraries like NumPy, Pandas, Matplotlib, sklearn, Seaborn, warning, so that if there is an update we don't get any warnings. First of all we will pre-process the data, then we will split it into X-test, X-train, Y-test and Y-train, and then we will train the model. After that we will take a look at its accuracy. First of all, we load our data. The data is basically USA housing data, and we load its shape and head. And here we can see average area income, average area housage, average area of the number of rooms, and average number of bedrooms, area population, the price of each house, and the address. What we will do is we will first of all remove the unnecessary columns that we don't need. I think in this data set we have to predict the price of the house. So we don't need the address of the house because the address has nothing to do with the price. In actual it has a lot to do with the price, but here the address basically does not show the physical location of the uh, plot or of the house, so we cannot get a better idea by assessing the address column that whether our house is worth that much. Like we don't know where is 208 Michael Ferry APT.674. So what will happen is we don't know whether it's a commercial area, whether it's uh, like rural area. So this thing can have a bad effect on our model's prediction. So what we will do is we will remove the address column first. We take the data info, and the data info says that there is no value, that is null, and then we create a heat map, and that also confirms that there is no null value. And then we remove the address feature. X is equal to 1 stands for column and X is equal to 0 stands for rows. And then we drop rows because we ain't having any rows that are 0, but still we will drop any rows with missing data. And then just to get a numeric summary of our data, we use the describe function. So now we are getting our model ready. First of all we will load the shape, and we come to know that we have 5000 rows and 6 columns. And then we split our data into feature variables and target variables: xtrain, xtest, ytrain and ytest. So first of all we create a variable x in which we place uh, everything from the data set except the price column, because that is what we want to predict. And in the target variable we store it in a y variable, and in the y column we place the price column. That is what we are trying to predict. So we have basically split our whole data set into features and target, so that we provide it into to the model for training. And now the shape of x variable, it consists of 5 columns and 5000 rows. Y shape, the shape of y column is 5000 rows. And now let's actually train our dataset using linear regression. First of all, what we do is we import train test split. It is a module from sklearn, and we make xtrain, xtest, ytrain and ytest. And what is test and what is ytest? Xtest is the data from the x variable that is to be used for testing, and similarly ytest is the data from the y column that is used for testing. And we spare some data for training so that the model can actually compare the results and provide better results. For that we make x test and y test columns representing both of the variables. So white train dot shape, we get to know that we have 4000 rows. X train dot shape, we have 4000 rows, 5 columns. Y train dot shape, X test dot shape, we get to know that we have 1000 rows. Basically it has split data on its own. There is a built-in functionality in sklearn that enables it to split data unanimously. And Now let's train our model, and what is from sklearn.linear underscore model. From the sklearn library we have imported linear regression model, and we have passed the training data to our model, xtrain and ytrain, and by the fit function we train our model. So our model has been trained, and now we want to test our model. So for that we will use the x test and y test uh, functions, and first of then we will use the predict function, and then we will use the x test and y test columns data, and after that we actually use this we actually make a variable called results, and in that we store y test and y prediction. Basically uh, we want to compare the actual values with the predicted values. So what our model has predicted versus what actually lies is, so that we can get to know what our model has worked. So this shows a relationship between the actual values and predicted values, and you can see there is a slight difference between the actual and predicted values. There's not much difference, so we can say that our model's accuracy is okay. We won't say good, because there is still a difference between actual and predicted value. And with that being said, we actually these are some plots, and this is our line of linear regression, linear regression that we made, and you can see that all of the data points it has plotted, and against those data points where all the data points were nearest to the line, it plotted a linear line, and that is our line of linear regression. So that was it from the linear regression. And then we have actually calculated mean squared error and root mean squared error. These are basically two evaluation metrics for the uh, regression and classification models, and they are basically used to predict the accuracy score for the models. And that was it from this session.